Section 5.4, Right Triangle Trigonometry. In this section, you will use right triangles to evaluate trig functions, use cofunctions of complementary angles, solve right triangles, and use right triangle trigonometry to solve applied problems. Let's start with the trig functions of any right triangle. Remember, our mnemonic friend SOHCAHTOA applies to any right triangle. So let's recall SOHCAHTOA. So we have an angle T here. Sine T is opposite over hypotenuse. Cosine of T is adjacent over hypotenuse, and tangent T is opposite over adjacent. So here is our angle T. This is the opposite side, the adjacent side, and the hypotenuse side. And this is a right triangle. And this right angle is never T or your theta. Alright, let's work on some examples here. Example number 1. Given the right triangle shown below, find the values of cosine alpha and tangent alpha. So this is your alpha, and these are the sides. So this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we want cosine alpha, and we know that's adjacent over hypotenuse. So that's why that is equal to 15 over 17. Next, tangent alpha. Tangent is opposite over adjacent, and that is equal to opposite is 8 over adjacent 15. Okay. Next, example 2. Use a triangle below to evaluate all 6 trig functions of the angle alpha. So again, this is our angle. With this, this is our right angle. So opposite of a right angle is the hypotenuse. So hypotenuse is 5. This is the opposite side, and this is the adjacent side. And remember our Pythagorean theorem, a squared plus b squared is equal to c squared. So we can solve for the opposite side. So that is 3 squared plus b squared, and the hypotenuse is 5. So 5 squared. This is 9 plus p squared is equal to 25. So that is, subtract 9 both sides. So b squared is equal to 16, and b is equal to 4. Square root both sides. So we want all 6 trig functions. Now we have all the sides. So let's start with sine. Sine is opposite over hypotenuse. So the opposite is 4. So that is 4 over 5. Then cosine, remember, is adjacent over hypotenuse. So adjacent is 3, and hypotenuse is 5. Then tangent is opposite over adjacent, so that is 4 over 3. And the other 3 trig functions, we have cosecant. Cosecant is, remember, 1 over sine, and that is 1 over sine is 4 over 5, so that's why this is equal to 5/4. And then secant alpha, we know that this is 1 over cosine alpha. Cosine is 3/5, so that's 1 over 3/5 is equal to 5/3. Then cotangent alpha is 1 over tangent alpha, and tangent is 4/3, so that is 1 over 4/3 is equal to 3/4. So these are our 6 strict functions of the angle alpha. Okay. So next, cofunction identities for complementary angles. A quick refresher, two angles are complementary if they both add up to, yes, 90 degrees. In a right triangle, the two acute angles are automatically complementary, so that means we get the following cool cofunction identities. So the first one is cosine t is equal to sine of pi over 2 minus t. So here, t and pi over 2 minus t are complementary. That means they add up to 90 degrees. Okay, take a look at this right triangle. We have alpha and beta. If we want sine alpha, if this is our angle alpha, so meaning this is the opposite side and this is the adjacent side and this is the hypotenuse, and we know that sine alpha is from SOHCAHTOA, it's opposite over adjacent hypotenuse, and we note that this is our A, this is B, and this is C. So opposite over hypotenuse, that is like B over C. While cosine beta, if this is our angle beta, meaning this is now going to be the opposite side, this is the adjacent side, and this is still your hypotenuse. And cosine beta, I'm going to use this space here. Cosine is adjacent over hypotenuse, and that is still gonna be equal to adjacent is your B and hypotenuse is your C. So that's why sine alpha is equal to cosine beta. So same thing with sine beta is equal to cosine alpha. Okay, so please remember all this. So tangent t is equal to cotangent of alpha over pi over 2 minus t. Then secant t is equal to cosecant of pi over 2 minus t. And again, remember that t and pi over 2 minus t are complementary. Example number 3. Letter A, if sine t is equal to 5 over 12, find cosine pi over 2 minus t. Alright, so take a look at this. Sine t is equal to cosine of pi over 2 minus t. So if sine of t is equal to 5/12, so meaning if this is your alpha, this is your beta, meaning this is also equal to 5/12. And I can show you using a right triangle. If this is our t, this angle is t, so sine is opposite over hypotenuse, so this is 5, and this is the hypotenuse 12, and then cosine, let's say this is beta, because this is alpha, and these two angles are complementary. When you add up these two angles is equal to 90 degrees. So here it's going to be adjacent cosine over hypotenuse, so that's why that is equal to 5/12. Letter B, if cosecant of pi over 6 is equal to 2, find secant of pi over 3. So cosecant of pi over 6, so here cosecant of t is equal to secant of pi over 2 minus the angle pi over 6, and pi over 2 minus pi over 6 is 2 times 6 is 12, 6 minus 2 is 4, 4 over 12 is pi over 3. So cosecant of pi over 6 is equal to secant of pi over 3, and cosecant of pi over 6 is equal to 2, therefore secant of pi over 3 is also equal to 2. Okay, and also if you notice here, pi over 6, that's 30 degrees, and pi over 3 is 90 degrees. So we can say that pi over 6 and pi over 3 are complementary. Okay, next. This time we're going to use trig functions to solve triangles. The real power of trig functions is that they let us solve triangles, that is finding any unknown side and angle. Let's take a look at example number 4. Solve the triangle below by finding all unknown sides and angles. What do we have here? We have the sides are A, 7, and C, and we have, this is the right triangle, and we have the angle here 30 degrees. So definitely this is 60 degrees. So let's say this is angle A, and this is angle B, and this is angle C. Opposite to angle A is side A. Opposite to angle B is, this is side B, and this is side C. Okay, so I'm just gonna list down our angles here. A is 60 degrees, B is 30 degrees, and of course our C is 90 degrees. And our sides, A, we need to solve this. B is equal to 7, and then also we need to solve for our hypotenuse C. Alright, let's start about solve side C. If you want to solve the hypotenuse, what do we have here? We have the angle 30 degrees and the side B. which is 7. So let's use that. If we use this angle 30 degrees and we want to solve for hypotenuse, and we have these opposite side, so we can use sine of 30 degrees is equal to opposite over hypotenuse, so that is 7 over c. And if we cross multiply here, it's gonna be c is equal to 7 over sine of 30 degrees, and what is sine of 30 degrees? Yes, that is equal to 1/2. So 7 over 1/2 is equal to 7 times 2, 14. So we have now c is equal to 14. So we're missing one side, which is a. So you can use Pythagorean theorem, or actually you can, if we have the two sides here, one of the you can use tangent if you want. Tangent of 30 degrees equal to opposite over adjacent, so that is 7 over a. And do the same thing, you'll be able to solve for a. 7 over tangent 30 degrees. Or you could use the Pythagorean theorem, a squared plus b squared is equal to c squared, to solve for the other side, which is a. So b is 7, so 7 squared, and c is 14. Then if you subtract 7 squared both sides, and we know that 14 squared is 196, minus 7 squared is 49. So that is a squared is equal to 147, and then square root both sides, so that a is equal to square root of 147. So now we were able to get our two missing sides. A is 14 and c is square root of 147. So these are all the angles and sides. Okay. Next, example number 5. A right triangle has one angle of pi over 3 and a hypotenuse of 20. Solve the triangle. So let's use this right triangle here, and we have the angle pi over 3. What is this other angle? So we can actually solve that. So let's say if this is x, so meaning pi over 3 plus x is equal to, since they are complementary, so meaning this equal to 90 degrees, which is equal to pi over 2. And if we subtract pi over 3, so x is equal to pi over 2 minus pi over 3, and that is equal to pi over 6. So this is pi over 6. So let's say this is angle A, B, and this is C, and the opposite sides, this is side A, this is side B, and C. So we're going to solve the triangle, complete all the angles and the sides. So we have the angles A is pi over 6. B is pi over 3. And C is 90 degrees, so that is pi over 2. Okay, so those are the angles, and then the sides. So what do we have here? Hypotenuse is 20, so C is equal to 20. Now we want to solve for A and B. So we can start with, so using pi over 3, solving for A, so that is, we need the adjacent side, so we can use cosine of pi over 3 is equal to adjacent over hypotenuse, so A over 20. So if we cross multiply here, this is 20 times cosine of pi over 3 is equal to A, and cosine of pi over 3 is actually equal to 1/2, and 20 times 1/2, A is equal to 10. Next is side B. So again, let's use Pythagorean theorem. A squared plus B squared is equal to C squared. Now we have value of A, which is 10 squared. So plus B squared, and C is 20. So 20 squared. Then subtract 10 squared both sides. 20 squared is 400. 10 squared is 100. So that is 400 minus 100 is 300. Then square root both sides. So B is 300 is 100 times 3. Square root of 100 is 10. So this is 10 square root of 3. So we have the three sides. A is equal to 10, B is equal to 10 square root of 3, and the hypotenuse given is 20. Okay. Next, using right triangles to solve applied problems. Trigonometry with right triangles is very powerful. We will use it to find heights, angles, and sides of triangles that can model a wide range of problems, like airplanes, GPS, buildings, and many other things couldn't exist without trigonometry. And that's why we are very thankful about it. Okay, so let's try some examples here. Example number 6. When I went for a hike the other day, I wanted to find the height of a tree. So I walked 30 feet away from its base, and measured an angle of 57 degrees from the ground to the top of the tree. Now the question is, what was the tree's height? So this is the tree. I walked 30 feet away from its base. So let's say this is 30 feet. And measured an angle of 57 degrees from the ground to the top of the tree. So this angle is 57 degrees. And we want to solve for the height of the tree. So let's say this is the height of the tree, and this is the given angle, 57 degrees, and this is the opposite side, and this is the adjacent side. So that means with an angle and opposite and adjacent, we need to solve, we use tangent. So tangent of the angle 57 degrees is equal to the opposite over adjacent. So let's say if this is angle A, so we can say that this is side A, and if this is angle B, this is side B. So here, that is opposite over adjacent. A over adjacent side is 30. Then we can multiply 30 and tangent 57 degrees. To isolate A, and use your calculator. 30 times tangent of 57 degrees, A is equal to 46.196. And since we're talking about the height, so that means that is 46.196 feet. And this is the answer. That is the height of the tree. Okay. Next one, example 7. A radio tower is located 400 feet from a building. Someone looks out a window in the building and determines that the angle of elevation to the top of the tower is 36 degrees, and that angle of depression to the bottom of the tower is 23 degrees. Now the question is, how tall is the tower? So let's say this is the tower and this is the building, and the tower is located 400 feet from the building. So this is 400, and someone looks out a window in the building. So let's say this is the window, and determines that the angle of elevation. So by the way, this is an example. This is an angle of elevation, and this is the angle of depression. So let's say from this window, angle of elevation to the top of the tower is 36 degrees. So from here to the top is 36 degrees. So this is 36 degrees. And the angle of depression to the bottom of the tower is 23 degrees. So here, so meaning this angle here is 23 degrees. So then we want to get how tall is the tower. So this is the height of the tower. So look at this. We have two right triangles. The first one here, we use the blue triangle here. We have this angle of elevation, which is 36 degrees. And we know that this is 400, because that's the distance from the tower to the building. And we can solve this. Let's say this is our first height, and this is 90 degrees, so that is like opposite over adjacent. So we can use tangent of 36 degrees is equal to this height here over 400. So meaning h1 is equal to, if we cross multiply here, is 400 times tangent of 36 degrees, which is equal to 290.617 feet. Next, we use an angle of depression to the angle to the bottom of the tower. We use this green right triangle here is 23 degrees. So we want to get this side here, let's say h2, and again that is opposite, and we have here as 400. So we can use a tangent of 23 degrees is equal to, let's say, h2 is equal over 400. So h2 is equal to 400 times tangent of 23 degrees. And when you use your calculator, 400 times tangent of 23 degrees is actually equal to 259.76 feet. And then now we want to get the height of the tower. How do we get the height of the tower? So from here to here, so let's say this is the height, and we can say that the height is equal to h1 plus h2. So you can use that to solve for the height of the tower. So that is, I'm going to use this space here, so h is equal to h1 plus h2, that is 290.617 plus 259.76. So the height is equal to, if we add this two, is 550.38 feet. That's how tall the tower is. Okay. All right. Now let's try to solve some lecture questions. Number 1, solve the following triangle. So meaning we have to complete all the 3 sides and all the angles. So what do we have here? So this is angle A. That's why we have here the opposite is the side A. And this is angle C, and this is angle B. So B is 60 degrees, 90 degrees, so definitely your A is 30. It's a 30, 60, 90 special right triangle. And we want to solve for the sides. We have, this is side B, which is equal to 10. What do we have? Angle 60 opposite over C. So meaning we can solve for sine of 60 is equal to opposite is 10 over the hypotenuse C. So C is equal to 10 over sine 60. And sine 60 is, yes, square root of 3 over 2. Get the reciprocal. So that is 20 over square root of 3. Then remember, rationalize the denominator. So that C is 20 square root of 3 over square root of 3 times square root of 3 is 3. Then now we have the hypotenuse. You can solve for the other side, which is A. You can use Pythagorean theorem. A squared plus B squared is equal to C squared, or let's use another method. And that is, if we use tangent, let's say, let's use the angle 30, that's opposite over hypotenuse. Oops, sorry. SOHCAHTOA, opposite over adjacent, so A over 10. So A is equal to 10 of tangent 30, and tangent 30 is square root of 3 over 3. So A is tan square root of 3 over 3. So now we have the three sides. A, tan square root of 3 over 3, B is equal to 10, and C is equal to 20 square root of 3 over 3. Okay. Next, number 2. For the following exercise, use the triangle below to evaluate each trig function of angle A. Let me erase all this. Given the two sides 4 and 10, then we can solve for the hypotenuse using Pythagorean theorem. So that's going to be 4 squared plus 10 squared is equal to c squared. So c is 4 squared is 16, 10 squared is 100, that's 116. So that is square root of 116. Now let's complete all this, assign the 6 trig functions. Let's start with sine A. SOHCAHTOA, if this is your angle A, so this is the opposite side, adjacent, and this is the hypotenuse. So sine A is 10 over square root of 116. And if you rationalize this, if you multiply by square root of 116 over 116, so that's going to be 10 square root of 116 over 116. Next, cosine of A is adjacent over hypotenuse, so that is 4 over square root of 116. And again, if you multiply this by square root of 116 over square root of 116, so that is 4 square root of 116 over 116. Next, tangent A, opposite over adjacent, that is 10 over 4. Next is cosecant A, which is equal to 1 over sine, so that is, we have 10 over square root of 116, so that is 1 square root of 116 over 10. Next, secant of A is 1 over cosine. We have here 4 over square root of 116, so meaning this is square root of 116 over 4. And cotangent of A, is equal to 1 over tangent, so that is 4 over 10. Okay. And the last problem, number 3, a 370-foot tall giant redwood grows exactly vertically from the ground. I walked a distance from the base of the tree and measured the angle of elevation from the ground to the top of the tree be 60 degrees, and the question now is, how far did I walk? Oops. So again, we have the redwood height is 370 feet and angle of elevation is 60 degrees, and we want to solve how far did I walk. So we want to solve for this. So let's say this is B. So what are we going to use? Yes, tangent. So we can use tangent of 60 degrees. That is opposite over adjacent. So 370 over B. Then we can solve for B. B is equal to 370 over tangent of 60 degrees. And what is tangent of 60 degrees? Yes, that is square root of 3. And we can rationalize this again by multiplying square root of 3 over square root of 3. So that b is equal to 370 square root of 3 over square root of 3 times square root of 3 is 3 feet. And that is the answer. Alright, so this is section 5.4. Let me know if you have any questions, and thank you.